Hello everyone! Today I will introduce our work, Mansion. Our goal is to generate multi-floor building scale, executable 3D environments from natural language in order to support long-horizon embodied AI tasks. Unlike prior environments that mainly focus on single rooms or single-floor homes, Mansion targets more realistic building environments such as offices, hospitals, schools, and supermarkets. Real-world embodied tasks are often building scale. Examples include office delivery, hospital supply transport, and multi-step household chores. These tasks require not only navigation and manipulation, but also spatial memory and cross-floor planning. However, existing simulation resources have clear limitations. Real-world scan data is expensive to collect and difficult to edit. Meanwhile, as shown in Table 1, existing generation methods mostly focus on single-floor or residential layouts, and often lack stairs, elevators, and explicit cross-floor topology. Mansion is designed to address this gap. Mansion is an MLM plus geometry hybrid framework. Given a natural language prompt, the system first performs whole building planning to determine the building function, floor structure, and vertical cores. Then, it generates room topology for each floor. Next, a geometric solver produces floor plans that satisfy boundary, topology, and vertical structure constraints. Finally, the system instantiates materials, doors, walls, and objects to create executable AI2 Thor scenes. One key innovation of Mansion is finding the right comfort zone for MLLMs in floor plan generation. Directly asking an MLLM to output room corners or polygons is unstable, because precise coordinates, room topology, and cross-floor consistency must all be correct at the same time. Another line of diffusion-based floor plan methods is more stable, but the MLLM usually acts only as a semantic translator, while the actual geometry generation depends on the training distribution. As a result, these methods struggle to generalize to open vocabulary building types such as hospitals, schools, and offices, and they cannot strictly guarantee vertical alignment of stairs and elevators. Mansion separates these responsibilities. The MLL handles building semantics, room topology, and local seed guidance, while the geometric solver performs candidate search, topology filtering, and layout verification. Experimentally, on the T2D benchmark, our method performs comparably to chat house diffusion. But on the more complex out-of-distribution ResPlan 1K benchmark, our method performs substantially better. The key takeaway is MLL plans and points, geometry solves and verifies. After generating the floor plan, we still need to turn it into a usable 3D scene. The key is not simply placing more objects, but making objects reachable, collision-free, and task-ready. Therefore, our object placement module shifts from quantity first to quality first. First, reachability is treated as a hard constraint. We also introduce group-based placement and new structural relations to generate regular layouts. As a result, Mansion achieves 100% reachability, 0 out-of-boundary objects, and 0 collisions without sacrificing the number of placed objects. In the user study, our scenes also show clearly better realism and layout quality than previous methods. Based on this framework, we built the Mansion World dataset. It contains more than 1,000 multi-floor buildings, ranging from 2 to 10 floors, with over 10,000 rooms in total. Unlike previous home-centric datasets, Mansion World covers residential, office, and public facility domains, including offices, hospitals, schools, supermarkets, and entertainment centers. It provides a natural difficulty progression from simple household tasks to complex public building tasks. Mansion also provides an executable ecosystem. First, we extend AI2 Thor with stair and elevator assets, and provide cross-floor atomic skill AP such as take stairs, call elevator, and use elevator. Second, the generated scene data can be transferred from AI2 Thor to Isaac Sim. Third, we provide a task semantic scene editing agent. It checks paths, objects, and container states, and then performs minimal edits to make tasks executable. In this way, the same building can be reused for many language-defined embodied tasks. Finally, we evaluate existing embodied agents in Mansion World. The task is to find a target object and deliver it to a specified destination. The result is very clear. As spatial complexity increases, success rate drops sharply. This shows that current methods still have substantial room for improvement in cross-floor planning, long-horizon memory, and visual grounding. Thank you for watching. We hope Mansion can serve as a useful testbed for future research on building scale embodied AI. Please scan the QR code for more details.